Hello and welcome back to this video series on static and dynamic data structures. In this video, I want to specifically talk about multidimensional arrays. In the simplest form, a multidimensional array is an array that contains other arrays. So for example, if we wanted to declare a single array that held all of the apartments on the first floor, we could just essentially say first floor, give the we'll say int, open bracket, close bracket, first floor, and then we'll do our open bracket and say 400, 440, 480. And actually, let me just go ahead and write that out here. So let's see here. So it would be something such as this. And don't forget our brackets. This means it's a single dimensional array. And we'll say something such as equals, and this is an array literal or collection initializer. And we'll say if we was only doing the first floor, it would be 400, 440, and then 480. Right, so that would be our array. But in this case here, a two-dimensional array, we want to basically mimic the data. We want to kind of bring in the data in our program and put it in what we would call a matrix form or a table form. So if you look at this chart here, it's more in a table structure. And so if not only just holding a list or just one line of information, but how do we hold data in our program that would be contained in the table? And in this case here, we would specifically use a two-dimensional array. In a two-dimensional array, if it's two, we would have to do two brackets. And this would be the way that we would do that when we would say, let's say that this is an apartment building, and we would say apartment. And then we would structure our array as such. And because this has, one or 0, 1, 2, 3, 4, 5, we would have 5 nested arrays in this two-dimensional array. So 1, 2, 3, and we would continue to populate this out. 4, I'm pretty sure there's a faster way of doing this, but let's just keep going here. So 1, 2, 3, 4, 5. Now, here's what I'd like for you to do. I would like for you to pause this video and to see if you can populate this array, right? And I'll give you a hint. The first row, this will represent row 0, and that would be 350, 390, 435, and so forth. So pause it. Go ahead and populate this here. And then what we're going to do is we're going to jump to a coding environment where I have a very similar example. I want to show you another way of actually declaring this array and then initializing it. And then we'll do a quick problem. Well, not a problem, but we'll work with this array in terms of how to actually call out information. And then that'll conclude the video. So pause this video and finish populating this array, or go to the coding playground, online GDB Java, and make sure you're using a Java playground, and then try to create this array. And then once you get done, then unpause this video and then we'll continue from there. All right, so hopefully you have something that looks like what I have here. And what this represents is this table, and this is the Java syntax for a two-dimensional array. So a few things I want to point out. For a two-dimensional array, we have 2 sets of brackets, right? And then also, we see that we have, like, if you could think of it this way, as an array that's nested within another array. In this case here, each one of these arrays here represent a floor in our apartment building. So 350, 390, 435 are all on floor 0. And then here, floor 1, we have 400, 440, 480, and so forth. This first row here, if we wanted to call out 350, that would be position 0, 0. And we're going to look at a coding environment and play around with this and actually run our program. And then also I want to point out is that whenever you're doing the array literal, you don't put a comma after the last array that you have within your multidimensional array. And so let's jump over to a coding playground and play around with this example a little bit more, and then we'll put a bow on this video. All right. So here I just took this Java syntax and put it into, I wanted to show you two different approaches. One approach here is kind of what we did in the previous video, where we can declare and initialize, create an instance of this array, and then declare that it's going to have 5, for this two-dimensional array, it's going to have 5 rows and then 3 columns. And then here's a way that we would actually populate this array. We can actually tug at each index within our two-dimensional array and assign a value. That's one way. It's very long, very lengthy, because we have to do all the permutations of this two-dimensional array. And so right now, I didn't finish this. I only got to the first 2 rows, which was 350, 390, 435, 400, 440, 480. But if I wanted to continue to go down and finish populating this array, I would have to do rows 2, 3, and 4. A second approach is the one I prefer, is this one here. So let me comment this out. Is this the collection initializer, or you could term it as array literal, because you're literally assigning a value upon declaration. And so here, again, it's kind of what we've seen in the slideshow over here. Move this over. And the way that we would call out a value in this two-dimensional array would be to call the name of the array, rent by floor and bedrooms, and BDRM is short for bedrooms. And if we wanted to pull out 440, we would go down, the array started at position 0, so we'll say 0, 1, and then that's the row, and then the column would be 0, 1, and then that would give us 440. And let me just bring out my marker here. Oops, can't use my marker. I'm not on my my screen where I can write on. But what I can do here is do a little text, right? Well, let's bypass that. But anyway, this is 0 where my mouse is hovering, 1, 2, and then here 0, 1, 2, 3, and 4. And so you could call out the individual values within this two-dimensional array by their index. And so a two-dimensional array is good for structuring out table data that we would possibly want to structure out in a table format or in a matrix. There is such thing as a 3-dimensional and a 4-dimensional array. You can even go up to 5, 6, 7, etc. What I want to do is pull up a seating chart from a stadium to look at what a 3-dimensional array would look like. We won't go into the details of the 3-dimensional array, but I want to give a practical example of how a 3-dimensional array could be used to structure data. All right, so here I have the Bulls Seton Stadium chart. And one of the things about this particular stadium is that we can actually structure out all the various seats in this stadium in our program if we wanted. It would take a long time to type that in, but if you can think of it this way, I'm going to just put in some code on to my right-hand side of my screen here. I'll say int, and I'll say seating chart. Well, let's be a little bit more descriptive. Bulls seating chart, or United Center seating chart. And what I'm going to do here is, I'm just going to declare, I'm not going to initialize it because that would take a long time. But if it's a 3-dimensional array, I'm going to put 3 subscripts. And what do you think these 3 subscripts will represent? The first one would represent the section. Let's say if it's section 302, 303, or 122. The second subscript would represent what? The row. Oops. And the third one would actually represent the seat. So we can actually create a 3-dimensional array to structure out data in our program to represent every seat in this stadium by using a 3-dimensional array in our program. So let's say, for instance, we wanted to declare and initialize a new instance of this array. We could say, we already know that these subscripts will say section, row, and seat. We could say new int, and then give the 3 items at the end here. And then we would say something, I'm not sure which the largest number here. Is it 330? That seems like it's 330, so it would be 330, 330 sections. And assuming that all the sections have the same amount of rows, so let's say that there's always 12 rows in the section. And then here would be the seat. And let's say, for instance, the seat would be, it could be like 1 through 23. And so that's how we would structure out our array. If we were to, like I said, this all depends on that. Each section has 12 rows, and each row has 23 seats. And we know that's not the case for the Bull Stadium. Like this section can have definitely like over 50 rows, while this section here could only have 10 rows. So let's just assume that that's the case, that each section has 12 rows and 23 seats. Now, let's say, for instance, we did want to really mimic this stadium in its true essence. There is something called a jagged array, where we could depict the different lengths of rows in different sections. I'm not gonna go through the details of that, but I would say do some research on jagged arrays, and it's just a different way where we can actually have different lengths of arrays within our multidimensional array. So, for instance, what I'm hovering at on my mouse is these all have the same length. There are 3 different apartments. All right, so apartment 1, apartment 2, apartment 3, apartment 1, apartment 2, apartment 3. But what if you had a floor that only had 2 bedroom apartments? Then that would look something like this. And that would be the case with a jagged array, is that these may be different lengths. And there are certain use cases where we want to mimic that data in our program. Okay, I'm going to put a pause on this video, and then I'll stay tuned for the next video.